Hi, I'm Denise, and welcome to Math for All, where everyone can learn more about math. Today, we will learn how to add, subtract, and multiply terms that include variables. This is important for the beginning of solving for variables, which is the essence of pre-algebra and algebra. We have very different rules between the adding and multiplying, so go grab our pre-printed fill-in-the-blank notes from our website, mathforall.net, where you can follow along and have everything you need to combine terms. Let's start off with an example, and then we'll go over the rules for adding terms. Remember that terms are groups of letters and numbers separated by plus and minus. Here it is. Simplify 5x squared plus 3a plus 2x squared plus y. First of all, we need to recognize that we are being asked to simplify this. We can't answer with a final number because we don't know what all the letters are and we can't solve for them. The word simplify tells us to just make this prettier. We will combine what we can, but first I will expand it out so that you can see what's going on. In the future, we'll skip this step. So our first term is 5x squared. I'll use this green color for him so you can see it better. 5x squared is 5 times x squared, which is the same thing as x squared added 5 times, remembering that multiplication is repeated addition. It looks like this: x squared plus x squared plus x squared plus x squared plus one more x squared. The next term is our light blue 3a. 3 times a, or a added 3 times. A plus a plus a. 2x squared expands to a yellow, x squared plus x squared. Our last term of y will just get put at the end here. Remember that y has an invisible 1 in the front, just one y. Now that it's all expanded out, see what we can put back together? Do you see all these x squareds? We can count up how many there are. 5 here plus 2 here equals 7 for 7x squareds. Added to that are the 3 a's and the 1 y hanging out. The final simplification is 7x squared plus 3a plus y. Notice that we cannot combine anything else. Great job hanging with that one. We won't solve these that way anymore, but it is good for you to see why we can only add what we call like terms, and you can see why the exponents don't change. Now you're ready for the rules for adding and subtracting terms in an equation or expression, and we'll practice some using these steps. First step, group all of the like terms. I guess we need to show you what like terms are. In words, they are the same variables raised to the same power. Usually that word definition doesn't make much sense, so here are some examples so you can easily see what are like terms and what are not like terms. Under my like terms column, let's figure out a like term to -4ab squared. A like term must have the same variables raised to the same powers. So another like term has got to have ab squared in it. The front number or coefficient doesn't matter, and it doesn't matter if it's negative or not. So I'll put a 7 in front for 7ab squared. The next one we will make a like term buddy for is 3x. We know it has to have just an x with any number in the front. I'll say -10x is his like term. You can put down whatever number you'd like, even 10 million or 27.4 or 14 over 263, as long as it just has the letter x after it. Let's show some quick examples that are unlike terms so that you can see the difference. Let's make an unlike term to our -4ab squared. There are infinite possibilities for this, but I'll put one that is kind of close to ab squared. 7ab is not a like term because that b needs to be squared. An unlike term to 3x could be anything without just an x. So I'll just put 3xy because it's close, but it doesn't have the exact same letters raised to the exact same numbers. Another unlike term would be 3x squared. That little raised 2 makes them unlike terms. Back to the rules in adding and subtracting terms. We're still on step 1. We find our like terms and group them together. Instead of rewriting them, we can get a little creative and surround each like term group with a different shape. You get to choose what you'd like to do, but some examples are clouds, circles, underlines, boxes, triangles, etc. So now our second step is to add the coefficients of the like terms. Remember, the coefficients are the numbers in front of the little letters. We just add them up. Let the letters go along for the ride. They don't change. The next step is really the least important. Make that answer pretty by writing the term with the highest exponent first. Then go down from there and list in ABC order after that. That is all you need to know to add and subtract like terms. Let's practice 2 examples. First up, we have negative 2t cubed plus 11s minus s squared plus 3t cubed minus 7s squared. Following my steps, we'll group any like terms we see. Starting with the negative 2t cubed, I see another t cubed over here. I'll put a fun cloud around them, including the signs in front of them, because they are attached too. 11s doesn't have a buddy because there's no other s term. I'll underline him so I don't forget about him. Negative s squared has this other negative 7s squared here that we can group. I'm going to box them up to see them better. That's it for the first step. Kind of fun, especially if we use different colors. On to the next step. We combine these like terms by adding their coefficients. And by adding, I mean subtracting if necessary also. Okay, my terms in the clouds, negative 2t cubed plus 3t cubed. I do negative 2 plus 3 equals 1. The t cubed is along for the ride for 1t cubed. We should write it just as t cubed for proper form. The boxed like terms are negative s squared and negative 7s squared. The first negative s squared has an invisible 1 like this. Plus negative 7 makes it more negative for negative 8. Add the s squared on the end for negative 8s squared. Let's not forget about the lonely 11s. Even though he doesn't get combined, we still need to make him part of the answer. T cubed minus 8s squared plus 11s. It's in proper form with the highest exponent first. Let's circle it and move on. Check out this next one. As I'm reading it, you can see if you can get started grouping. We have 7 plus 36xy minus 4x plus 10x minus 10xy plus 2. I hope that you can see that all these have like terms buddies. Even this 7 has the 2. They are officially like terms because they have the same letters, which are none, raised to the same powers. I'll cloud them. I think the clouds are my favorite. 36xy and negative 10xy are also like terms. They'll get triangles like this. Negative 4x plus 10x will also be combined, so I'll go with boxes around them. We'll take care of the clouds first. 7 plus 2 equals 9 for our first term. Triangles. 36 minus 10 equals 26 with the xy right after it. Then our boxes. Negative 4 plus 10 equals 6 x's. We have to put these in order of highest exponent first, which there aren't any, but this xy here has 2 letters, so I'll decide to put him first. 26xy. The x term will be next, plus 6x. The plain numbers go last for +9. Awesome work. Now we will learn how to multiply a group together. I really can't say multiply terms because terms are added and subtracted. I want to teach this at the same time as adding terms because the steps are so different, it's easy to get confused about what to do. My advice to you on multiplying numbers and letters together is to forget everything I mentioned about like terms and letting the letters just hang out. This is completely different. Here are the rules for multiplying variables and coefficients. Don't worry about like terms. No boxes and clouds on this one. Second step, multiply all the numbers together. Third, multiply all the variables together by adding the exponents of any of the same letters. We'll go over this in case you haven't seen it before. And the fourth step, be sure your answer is pretty by putting the number in front and writing any letters in alphabetical order after it. It's always easier to do an example to see what these instructions mean. Here it is. -5x squared times 3a times 2x squared times y times a cubed. When multiplying, we get to squish them all together into one term. Let's multiply the numbers. We have -5, 3, 2, and that invisible 1 in front of the y, and a second a we can just ignore. -5 times 3 equals -15. Then that times 2 is -30. That will just be the number in front of our mashup. Now let's look at the letters or variables. We have x squared, a, another x squared, a lonely y, and an a cubed. Those two x squareds are going to get combined. In adding, we would leave the x squared as it is, but in multiplying, they don't stay as x squared. Let me show you what's going on here. X squared is x times x, and I'm multiplying it by another x squared, so times another x times x. X squared times x squared is x times x times x times x. So there are 4 x's multiplied together, and that equals x to the 4th. I'll put that right next to our -30 here. Next up are the a's. We have an a and an a cubed to multiply together. I'll do the same exercise in writing it all out, and then I'll show you what we're actually doing. A times a cubed is a times whatever a cubed is, which remember is a times a times a. We have 4 a's multiplied together, which is a to the 4th. We are actually adding the exponents of any of our variables like this. A times a cubed. The single a has an invisible 1 as his exponent like this. I can box the 1 and the 3, put a plus between them, and then it equals a to the 1 plus 3, which equals 4. Back to our combining. We're at -30 times x to the 4th times a to the 4th. We just have a y left, and so he's going to get plopped at the end. Our last step is to put the number in the front, check, and then put the letters in ABC order. So a to the 4th goes next, then x to the 4th, and then y. For our final answer of -30, a to the 4th, x to the 4th, y. All these are multiplied together, but no need for multiplication signs. They're invisible. Before we do some examples of combining letters and numbers by adding, subtracting, and multiplying, let's practice this multiplication by adding some exponents with 2 more examples. By the way, we will also learn to divide these, but that will be in a future video because you won't need those yet. First up is z to the 6th times z to the 5th. We don't have to write all these out now. We can box the 6 and the 5 and then add them up, which equals 11, for an answer of z to the 11th. Now this one, -3a squared, b, times -7a to the 6th, b squared, c. We'll take the numbers first. Remember that the negative signs in front of them are attached to them. -3 times -7 equals +21. I'll put that here. Look at the a's. I have an a squared times a to the 6th. I add their exponents. 2 plus 6 equals 8 for an a to the 8th. For the b's, we have b times b squared. Adding up their exponents with the invisible 1 on the lonely b, we get 3 for b cubed. And let's not forget the c on the end for a final answer of 21a to the 8th b cubed c. Awesome work! For our last example, we will combine everything you learned today by having to multiply numbers and variables and groups and then add or subtract any like terms. For this, you will have to remember the rules for doing both and be able to change your thinking as you're doing each one. We'll walk it through so it won't be so bad and you'll get a feel for it. Here we go. We need to simplify this mess. 6x squared times negative 4xy plus 5y cubed times y minus x cubed y plus 6y squared times 2y squared minus 2x squared times 3x to the 5th y squared. Wow, I sure hope this turns into something a little better. I do have to say, if you can deal with something that looks like this, you are on your way to being an algebra winner. First thing we're going to do is multiply anything we can within each term, the groups separated by plus and minus. And then we'll add any like terms that we see. Our first term, multiply the 6 times negative 4 equals negative 24. We have an x squared times x. 2 plus 1 equals 3 for x cubed times the y. Our next term just starts with a 5. Then, for the y's, I add their exponents. 3 plus the invisible 1 equals 4 for 5y to the 4th. Minus x cubed y is just fine the way he is, so we'll just copy him down. 6 times 2 equals 12. The y's are y squared times y squared is y to the 4th. Negative 2 times 3 equals negative 6. X squared times x to the 5th is x to the 7th, and the y squared at the end. See how smart you look? You knew what to do with those crazy numbers and letters. Now, to further simplify, we will seek out and group any like terms where they have the same letters raised to the same powers. Can you spot them? The first and third terms get clouds, and the second and fourth terms will be underlined. Remember, when we add like terms, the letters do not change. They just hang out after the numbers. We'll start with the first term, negative 24x cubed y, and the third term, negative x cubed y. Now, to combine these, we take their coefficients and combine them. And we leave the letters the same because we are adding, not multiplying. Negative 24 minus the invisible 1 in front of the other term equals negative 25 x cubed y. Next up, our underlined terms of 5y to the 4th and 12y to the 4th. You know what to do. Add 5 plus 12 equals 17 for 17y to the 4th. That last term doesn't get to be combined, but he is part of the final answer, so I'll just write him here. Minus 6x to the 7th y squared. So the big mess got a little bit better, but it still looks a little crazy. You have learned a lot in this video, and it can be confusing switching between combining like terms and multiplying within terms. But just remember the rules and go through it the way we did these examples. These skills will help you tremendously in your future math classes. So go print out a worksheet that has practice tailored to this lesson at my website, mathforall.net, and then keep going so that you can learn more about math.